So the purpose of this video is to show the setup for our coefficient of friction and our value of frictions lab here. We've got these little pieces of flooring. You'll notice there are two different sizes of them. One's approximately half the other size. We also have the spring scale. Although I've taped over the area where you can get confused with grams. We're focusing on, it measures forces, which is the SI unit of force is the Newton, and so you can, when this pulls, we can get a value there. And there are multiple areas and in fact you will find a few different times when you do this when your results aren't exactly what follows the principles that are known in physics, but we do get a pretty good example of what's going on. You're going to have these masses. I've already written the weight of them. They weigh 2 newtons. And so basically what you're going to do, and you start out, we'll do the narrower block. You're going to start out with the top side down. That's the black side up. And the instructions, the table will walk you through this. But when you set these on here, that would be with 2, 4, and then of course here we would have 6. But in this case we would have 6, we would have the small block, and we would have the top side down. And I may have to slide this over here. Try to get this so it'll work. There, I went ahead and tied an extra knot here. You'll of course be pulling it from way out here. It's way easier, but to get it on this camera, I tied a little knot here. And what you're basically going to do, and you may find that you want to record this with a video camera, you're going to be watching this forces here as you start to pull the item. And a couple of things I've noticed, especially with the top side down, you're going to notice this thing moves. I keep putting more and more force on it, more and more. All of a sudden it like jumps like that. To get it moving to start with, that's the value of the kinetic friction. Once it's moving, there's going to be another value. So if you video this and you pull it until it jumps, and then pull it at a steady rate, you're actually going to get two values. The first value is when it initially goes up and then jumps like that. And then the second value is what's it take to keep it going at a steady, kind of steady along here. Not too fast, not too slow, sort of the Goldilocks. That's going to be those two values. And you're also going to want to make sure and do this. This black surfaces in the classroom work nice. Some kind of smooth surface. You don't want to be keeping the surface the same. That's at least the start of this. Of course, if it wants you to put the other side, flip the other side over, and you're going to do, say 2 newtons there. The interesting thing about the black side, I'm not going to have you do kinetic and sliding friction because this is sort of a squishy, rubbery surface, and you don't see as dramatic a difference when you come with different surfaces. So we'll just do the sliding friction for the black surface on the black surface. Thank you, and I hope this helps.